For the next couple of weeks, we are going to be talking about exponent rules. We're going to start with integer exponents. You have this sheet, or should. This sheet covers all of the exponent rules. We are only going to talk about a few of them today. We're going to talk about the bottom two. I'll pull this out every time to talk about the new ones that we are learning, but specifically we're going to start talking about integer exponents, which is the last two specifically. So when we have this a is an integer, when we have any value number with a negative in front, so a negative exponent, to change that we are always going to put it over a 1 in a fraction bar. I obviously need a new pen. So we have 1 over x to the a, which is that number. Notice it is not negative anymore. But the rule is that if we have a negative exponent, we put it on the bottom of a fraction, which will change it to a positive, and we put 1 on top. The next one is 0 exponents. Anything raised to the 0 power is 1. These are the two rules we're going to focus on today. We're going to look at some examples with that on this next foldable. So this we will come back to throughout. Let's look at the next foldable, which is integer exponent practice. Alright, so we've got numbers 1 and 2, 3 and 4, all of them dealing with a negative exponent, which based on the rule, that means we are going to write a 1 over 5 to the third power. Now we can simplify that if we would like to. To continue simplifying it, we would have 1 over whatever 5 to the third power is. So 5 times 5 is 25, times 5 again is 125. So our final simplification would be 1 over 125. Same with number 2. I have a negative exponent, so I'm going to have a fraction bar. I've got 1 and 2 to the 6th power. And 2 to the 6th power is 64. So my solution is 1 over 64. Not necessarily solution, I'm not solving anything, I'm just simplifying as it states here. Alright, notice, and this becomes very important, that my parentheses are around the negatives inside those parentheses. That means when I actually move it, I leave it like that. I have a parentheses negative 5 squared. The reason why I leave the negative 5 in those parentheses is because then I have negative 5 times negative 5, which is 25, positive 25. There's my simplification there. It is a little different with this one. The negative is still going to stay in front of the 4, but it's going to stay outside of the parentheses. So 1 over negative 4 to the third equals 1 over, here is how these with negative outside works. You have 4 to the third power, so 4 times 4 times 4 again. 4 times 4 is 16, and then times 4 again is 64. So I have 1 over 64. The negative in front, though, lets me know that the entire thing is just going to be negative, because it is in front. Okay. Likewise with this one, if there's just a negative in front, there's no negative inside parentheses like there was here, my final answer is going to be negative. I don't know what yet, but it's going to be a negative. Anything raised to the 0 power is 1. So my solution for number 5 is negative 1. And number 6. If you're doing these by yourself, you should pause them between some. Make sure you can get the correct answer. Number 7 is one of those especially. It is worked just like 3, 4, 2, 1. They're all the same, except for number 5. So I have 1 over 7 squared. I'm just going to leave parentheses wherever they show me to them. I really didn't even need the parentheses there. It wasn't going to change the answer. But 1 over 49. This is simplifying with numbers, so I'm going to simplify as much as possible. I'm now going to do some without numbers, with just variables. I actually will be, as the directions say, evaluating each expression. So 7 through 12 is talking about evaluating, meaning I'm going to plug the number in. I am going to go ahead and plug the number in at the end, after I have simplified and gotten rid of my negative exponents. So, I have d to the negative third. So if I'm simplifying d to the negative third power, I'm going to have 1 over d to the third power. It's no different than what we did on the front, except we now have a variable. I'm then, because I am evaluating, going to plug in negative 2. So 1 over, I'm going to put it in parentheses when I plug it in. Now that I've plugged it in, I'm going to determine negative 2 to the third. Negative 2 times negative 2 times negative 2. That will give me negative 8. So negative 1 over 8 or 1 over negative 8. And it's the same. No matter where the negative is, the final solution is negative. Alright, now I'm going to bring down this a to the fifth, b to the negative sixth. This one is a little different. I'm looking specifically at what is a negative exponent. What has a negative exponent? B to the negative 6 is the only thing with the negative exponent. So when I move it, that's all that's going to move. A to the fifth is not a negative exponent, so it is going to stay in the numerator. B to the sixth becomes positive only by moving it to the denominator. I'm then going to plug in a 3 for A and a 2 for B. I'm then going to plug that in my calculator to simplify it. I'm going to go ahead and just do it all at once in a fraction. So 3 to the fifth, 2 to the sixth. That does give me a rather large fraction, 243 over 64. The calculator would reduce it for me, which means this is simplest form, and I do want you to leave it as an improper fraction. So 243 over 64. Just like a few minutes ago, if you're working on these while watching the video, it's a good idea to pause it, kind of look at some of these, make sure you can get the answers without me. Number 9, notice the parentheses around the whole thing, b minus 4. That means in order to have a positive exponent, which is our end goal, we never want a negative exponent, we are going to move the entire piece, b minus 4 squared. Whatever the negative exponent is attached to is what you have to move. I'm then going to plug in a 1 for b. That is 1 over 1 minus 4 is negative 3 squared. That becomes 1 over 9. 1 over 9. You could have done what we did up here, where you plug it straight in the calculator at this step right here. You can choose that. Okay, similarly, number 10, I've got 5z to the negative x power. This is very similar to number 8. Each of these pieces is separate. There's like little multiplication between them. There was a multiplication between this. I have to decide each piece whether that is got a negative exponent directly correlated to it or not. 5 does not have any exponent, so it is going to stay in the numerator. Z has a negative exponent of x, so I'm going to move z to the denominator and make the x positive. I'm now going to plug in z and x. 5 stays the same. Z is negative 3. X is 2. 5 over negative 3 squared is 9. Again, leave them as fractions. It's easier to worry about. You don't have to worry about how much you have to round it or anything like that. Okay. Again, good idea to pause it. See if you can try these on your own. number 11. Since this is in parentheses, see, these are the exact same problem almost, except this is in parentheses. Having it in parentheses means we don't have the negative exponent only with z. We now have it with the entire piece here, which means when we move it, we have to move the entire expression there, the entire piece. So I have a 1 in the numerator and 5z in parentheses, because it's in parentheses, to the x in the denominator. Then plug in z is -3, double parentheses there, raised to the second power. Again, I could plug it straight in my calculator if I wanted to. 1 over -3 times 5 is -15 squared. And that solution is 1 over 225. 1 over 225. Last but not least, for the evaluating section is number 12. I'm looking at each piece. I'm going to go ahead and write it down. It helps me out. So each piece. I'm going to go ahead and draw my fraction bar. That's a good first step. -3 is directly tied to c. That means it needs to change positions. -2 is directly tied to 16, so it needs to change positions. Nothing needed to stay in the numerator, so we are going to place a 1 up there. I'm now going to plug in 4. 4 to the third and 16 squared. All this is multiplying everything, which is, like I said, you can figure it out without a calculator. Calculators do make it easier, but so alpha y equals 1 over 4 to the third power times 16, and I'm putting in just like it shows. It didn't change anything. You've got this 6.103515625 to the -5. Here's why you have that. This is telling you that this decimal is, that's scientific notation, by the way. This decimal is so large that they're not going to write it in a fraction of any type. That if I wrote it down as a decimal, I'm just doing this as an example, we're not actually going to do any decimals, I would take that value and move it to the left 5 places. 1, 2, 3, 4, 5. So it would be 4 zeros, decimal, 40610. I'm going to leave the answer like this if I get a solution in scientific notation. Okay, last but not least, we are going to simplify. Simplifying means I have just variables. I'm just going to move things around. I might have to change simplify some numbers, some fractions. It doesn't mean I will have to, but it could happen. Alright, my goal is to not have any negative exponents or any zero exponents. I currently have a -4 raised to t raised to the -4th power. So I want to change this so that I do not have that. So -4 is directly related to t. That means t to the 4th moves. I do not have anything left in the numerator, so I'm going to put a 1. So 1 over t to the 4th would be the solution. This, number 14, is similar to number 10 or number 8 from the opposite page over here. Again, if you're doing this by yourself, it's a good idea to pause and think about things before you just watch them happening. So what's actually going on here is we have 3 times r to the -5th. 3 does not have a negative exponent, so it is going to stay in the numerator. R has a 5 exponent. So that means it is going to change positions. So my solution, my simplification, not solution, is 3 divided by r to the 5th. I like to always start by going ahead and putting a fraction bar. I might not end up using it and I might have to erase it, but 15. This is something we haven't necessarily seen before. That's okay, we can fix that. I have s to the negative 3. S does have a negative exponent directly with it, so it is currently in the numerator. It needs to change positions and go to the denominator so that that 3 can be positive. This is what I mean by we haven't seen this before, and that's we have a negative exponent in the denominator. It is going to need to change positions as well. So if it's currently in the denominator, to make it a positive exponent, it has to go to the numerator. So they changed positions. This one was negative, we changed it to the bottom. This one was negative, we changed it to the top. 16 is our 0 exponent rule. Anything to the 0 power is 1. Even in a variable, h to the 0 is 1. The 3 stays the same. Okay. 17. We're looking at every single piece because it starts to get a whole lot here. This is 2 times x to the negative 3rd times y to the negative 2nd all over z to the 4th. We're going to look at every single piece. 2. 2 does not have a negative exponent. Leave it alone. X to the negative 3 has a negative exponent. We are going to bring it and only it down to the denominator. Y to the negative 2 does have a negative exponent. So it was currently in the numerator. It needs to come to the denominator. Okay. I've gotten the entire numerator figured out. Now I'm going to go down to the denominator. Z to the 4th power. There is no negative exponent, so it stays in the denominator. So 2 all over x to the 3rd, y squared, z to the 4th. Number 18. Likewise, I'm going to look at every piece. It's a good idea to pause this video, try this one out. I have 4 times f times g to the negative 5th divided by 5 times h to the negative 3rd. I'm going to work with the numerator first. 4 does not have a negative exponent directly tied to it, so I'm just going to bring it over. Stays in the numerator. F, likewise, has no negative exponent, so it stays in its current location. G has a negative exponent, so I'm going to bring it down. G to the 5th power is currently in the numerator. Since it has a negative exponent, we want to undo that. We're going to bring it down to the denominator. I've taken care of everything in the numerator. Let's look at the pieces in the denominator. 5 does not have a negative exponent. I'm going to put it back in the denominator. Now I put it in front because that is actually standard form that we're going to talk about later. Put the numbers, then you actually put the variables in alphabetical order. So we're going to put it in front. Alright, and last, h to the negative 3rd. That is a negative exponent. It is in the denominator, so it needs to come to the numerator. And then we are finished. I know we're finished because we don't have any 0 exponents or any negative exponents. That's how you know that you have completely simplified the problems. There are your integer exponent rules.